Hi everyone, today we are going to continue with solving trig equations. Today we are going to approximate using our calculator. So today it's really important to be aware of what mode you need. Today we are going to be dealing with degrees, and we can see so because it says 0 to 360. But you want to make sure that your mode is correct and that you are in fact in degrees or radians if necessary for these approximations. And then you want to always think about where are your answers going to come from? Where are things positive? Where are things negative? We always want to start with that reference angle and find our corresponding buddies from there. So if we look at example number 1, as we start solving this trig equation similar to what we've been doing before, try to get everything to one side. So we can move over the sign as necessary. So we're adding one sign over here, and then we could subtract the 7 over. So we end up with -3 on the left, and then that equals 5 sine theta on the right. Divide over the 5, we end up with, where is sine of theta equal to -3/5. So we see that this is not a value from our unit circle, but we can approximate that value. Now, sine is negative in quadrants 3 and 4. So we know that's where our two answers are going to come from, quadrants 3 and 4. But what we're going to do first is find that reference angle. Now, I personally like to just type in the positive of this. Where is sine equal to positive 3/5? That's at, positive 3/5. That's going to occur at 36.9 degrees. So that's our reference angle. That's our quadrant 1 value is 36.9. But again, we know our two answers have to come from quadrants 3 and 4 where it's in fact negative. So one of our answers, we're going to take 180 plus our reference angle of 36.9. And then our other answer comes from quadrant 4 where we take 180 minus that reference angle of 36.9. So our two answers are going to actually be 216.9 and 323.1 degrees. All right, the second one is dealing with a cosine, very similar to that. You try that one on your own. In number 3, we have a secant problem. And in this case, we want to make sure we isolate so that we have 2 secant theta on the left to subtract over the 3 from both sides. So we get -3, divide both sides by 2. We get where is secant of theta equal to -3/2. Well, we don't have a secant button on our calculator, but what we do have is a cosine. So in order to flip that into cosine, we can flip this fraction to be 2/3 so that we can actually find that answer. Now, cosine is negative in quadrants 2 and 3. But again, I like to start off, we want to find that quadrant 1 reference angle. So I'm going to take cosine inverse of positive 2/3 to find my quadrant 1 buddy. That's 48.1 degrees. But again, I know my two final answers have to come from quadrants 2 and 3. So to get quadrant 2, I'm going to subtract away the reference angle. And to get quadrant 3, I'm going to add that reference angle to 180. And we get our two answers of 131.8 and 228.2. All right, there's another one for you to try. This time we are dealing with a cosecant. All right, now, in number 5, it is very tempting to move over that tangent to the other side and try to cancel things out. But what we're going to do instead is look for that GCF between the two, the greatest common factor. What we notice is both of these have a tangent that we can divide out as a GCF. So remember that tangent stays on the outside then, and when we divide out tan squared divided by tan, we're left with just the 2 tan, and then tangent divided by tangent is 1. Remember, this doesn't equal 0, tangent divided by tangent is 1. From here, we now have two pieces that we can set equal to 0. Where is tangent of theta equal to 0? Where is 2 tangent theta plus 1 equal to 0? AKA, if we subtract over the 1, and divide by the 2, where is tangent equal to 1/2? Now, similar to yesterday, tangent equaling 0 is actually going to come off of our unit circle. Not everything is going to officially on here be dependent on our approximation. We know tangent is 0 at 0 degrees and officially over here at 180 degrees. So theta is going to equal 0 and 180. Those we know from the unit circle. Tangent equaling negative 1/2, though, is going to happen in quadrants 2 and 4. And tangent equaling negative 1/2 is not a value from the unit circle. So again, I'm going to use my reference angle. So we have 26.6. That's the quadrant 1 value. And then I'm going to take that 26.6 and to find the quadrant 3 value, quadrant 2 value, I'm going to take 26.6 and subtract that 180 minus that. And then to find quadrant 4, I would do 360 minus that. So again, my two answers are going to be where the tangent is negative this time. So that would be at 153.4 and 333.4. So officially, all 4 of these are going to be answers to this equation. All right, there is a similar one for you to try using sine. On the last page then, we have a couple others to look at. Number 7 is dealing with actually a difference of 2 squares. So reminder, when we have a squared minus b squared, we can factor that to be a plus b and a minus b. So in this case, what squared is 4 sine squared theta? What squared is 25? Well, 2 squared is 4. And then sine squared is sine squared. And then 5 squared is 25. So we have our a and our b values. So 2 sine theta plus 5, 2 sine theta minus 5 end up being our answers here. And we're going to end up setting both of these pieces equal to 0. And when we subtract over the 5 and divide by 2, add over the 5, divide by 2, we get where is sine equal to positive or negative 5/2. Well, a reminder, if we try to take even the quadrant 1 value of 5/2, we know that sine cannot have an inverse that is bigger than 1 or smaller than negative 1. So it gave us an error message. And again, this is even going to be true for the negative 5/2. If you want to look at it that way, we get that error message because that is too big of a value. Okay, so what's happening is actually both of those with the sign are not possible. So we would say there is no solution officially to this particular example. Our next example is going to also deal with factoring, but this time we have a nice example of a type 1 factoring. So we have here that what multiplies to be 4 adds to be negative 5. This is going to be at negative 4, but and negative 1 that are going to multiply to be positive 4, but add to be negative 5. So we would say cosecant of theta minus 4, cosecant of theta minus 1. And we want to set each of these pieces equal to 0 to see what the values would be. So we want to know where is our cosecant of theta equal to positive 4? Where is our cosecant of theta equal to positive 1? Well, reminder, cosecant is not on our calculators, but sine is. So if we flip this fraction from being 4 over 1 to 1 over 4, we could look at the sine. If we flip this fraction to be sine of theta equals 1 over 1, which is still 1, right, we can find our answers. Now, the sine being positive 1/4 is going to come in quadrants 1 and 2 where sine is positive. So we would take sine inverse of positive 1/4. That is our quadrant 1 value this time of 14.4, if we could actually type this in correctly. There we go, 14.5 officially. And then we would also want the quadrant 2 value. So if we do 180 minus 14.5 minus 1 time, we would get 165.5. So those are our two answers that are going to come from the first part. 14.5 degrees and 165.5 degrees. Whereas sine equal to 90 is actually going to come from our unit circle, sine equal to 1. That's going to happen up at 90 degrees. And we could also use our calculator to double check that, but sine inverse of positive 1 is happening up at positive 90 degrees. So that's the third answer on that one. And that's the other place that will happen. All right, our last example, I apologize for the typo here. I want to change this, though, to be a tangent. So where is tangent squared theta minus 2 tan theta minus 8 equal to 0? So we just make that into a tangent. Well, similar to the last problem, we want to multiply what multiplies to be negative 8, adds to be negative 2. In this case, that's going to be negative 4, but positive 2. So we have tangent theta minus 4, tangent theta plus 2, and we're going to set each of those equal to 0 so that we end up with where is tangent equal to positive 4 or negative 2 after we set each piece equal to 0. Well, reminder, tangent, unlike sine and cosine, you can take a tangent of a number bigger than 1. So if we take tan inverse of, in this case, 4, we get 76 degrees. And tangent is going to be positive at that value in quadrant 1 as well as quadrant 3. So again, 76.4, 76, I believe, 0.0 is actually our reference angle. And if we do 180 plus that value of 76, we get, 180 plus 76 will give us our quadrant 3 value of 256. So two of our answers are going to come from that piece. So 76 degrees and 256. Now tangent is equal to negative values in quadrants 2 and 4. Again, I always like to find the quadrant 1 value first. So tangent is equal to 2 at our quadrant 1 value of 63.4 degrees. But again, really we need the quadrant 2 values, which is going to be 116.6, and our quadrant 4 value for the place that it will also be equal to negative 2. So that's 296.6. So officially then, all 4 of these are going to be our answers for this last one. The last one I want you to try on your own, you are looking where we have sine squared plus 4 sine minus 5 equal to 0. Thanks everyone for watching. We'll work more with these in class.